let's now look at what's called the expected value of perfect information, or EVPI. So what if we know what is going to happen? What if we have perfect information? Let's have a look at that. Okay, so hopefully obtaining perfect information doesn't look like this. Okay, so if we know exactly what's going to happen before it happens, and we're making certain decisions, well, it's very helpful. What is the expected value of that? So the formula is the following. The expected value of perfect information is the expected value with perfect information minus the maximum EMV. So just be so careful. There's of and with for both the expected value of sample information and the expected value of perfect information. And this EV with PI, that's our expected value with perfect information, which is actually our expected value of all of our max payoffs for each outcome. And again, we're going to calculate that in a minute. And the maximum EMV is just all your regular EMVs, grab the maximum of those, which is what we usually quote as our EMV value anyways. So back to our pellet example, it was 7.95 million. Okay, and finally, our EVPI is our expected value of perfect information. So like I was saying before, there's really an of between the EV and the PI, where PI means perfect information, EV stands for expected value. Okay, now let's talk about the formula for the expected value with perfect information. So here it is, and let's talk about what these terms are in here. Okay, so what we do is we look at all of the max payouts for each outcome. We look at the payouts for each outcome, take the maximum of those, and times it by the probability of the outcome occurring. Do that for each one, sum up those products, and that gives you your expected value with perfect information. Okay, let's start trying this out in Excel here. Okay, so here we are with this problem in Excel. We have our payoff table from before, we have our expected values, and again, those expected values are just generated using the sum product with the payoffs and the probabilities. And now, if we want to get the expected value with perfect information, we do the following. We take the maximum payoff with each event, if you will. So our two events are the following. Either demand increases, or it's large, or there is no increase, or it decreases. Okay, so for the increase option, this one right here, the maximum we could make is the 13.5 million. So if we had perfect information, if we knew demand was going to increase, we would definitely build the plant and make 13.5 million. So the expected value with perfect information takes that value and times it by the probability of demand increasing. Now, if you want to get fancy about this, what you can do is you can do a max call between all of the possible payoffs here for each outcome. So in this case, do a max between these two. It's going to grab the 13.5 million, times it by the 90%. Now we're not done. We do the same here. We take the maximum of these two payouts here and times by the 10%. Okay, so what we're doing, if we know that demand is going to increase, we're going to build that plant and make 13.5 million. If we know in advance that the demand is not going to increase, then we do not build the plant and we make the 1.63 million. This is going to happen. This is going to happen 10% of the time. This is going to happen 90% of the time. That is our expected value with perfect information. Now our max EMV is just the maximum of these two, which is what we normally grab for our EMV anyways, which is that 7.95 million. Just take the difference between these two to get to your EVPI. Okay, and then just back to our PowerPoint here. Let's just conclude talking about the expected value of perfect information by also comparing it to the EOL, which is your expected opportunity loss, which is also the same as your minimum expected value from your regrets. Again, see the regrets in EOL video to step you through how to get that EOL. Okay, And so, key thing to note here, the EOL is equal to our expected value of perfect information. Okay, so it turns out our EOL, or our expected opportunity loss, will also be the 4.37 million. So that expected opportunity loss is the same as our expected value of perfect information, or if you will, the amount that the perfect information is worth to us is equal to the amount we expect to potentially lose out on in earnings, which is our opportunity